Hello folks, this is 2019 February March session, paper 2 and the question number is 5. This question is concerned with the chapter of waves as well as the superposition. So the question says that by reference to two waves state the principle of superposition. It means this principle states that when two waves meet at a point, the resultant displacement or amplitude of the body is equal to the sum of individual displacements or amplitudes respectively. So the next is what's meant by coherence. Coherence means that the two waves performing interference or participating in the interference should have a constant phase difference. It doesn't need to have the same phase, but the phase difference should be constant at a particular point over time actually, so you have to mention over time as well. Now in question number B, two coherent waves P and Q meet at a point in phase and superpose. Wave P has an amplitude of 1.5 centimeter wave P, so it is AP is equal to 1.5 centimeter, and the intensity of this wave is equal to simply I. The resultant intensity at the point where the waves meet is 3I, so the resultant intensity is, so I resultant is equal to 3I. So now we have to find the amplitude of the next wave. It's not the resultant amplitude, but we have to find the amplitude of the next wave. So let us say the amplitude of the next wave is, so it is AQ equal to what, and we have IQ is also equal to what. So first, if I read these two things, I must have the intensity at P should be equal to some constant AP square, which gives me I is equal to some constant then 1.5 square. Now for the resultant wave, so we have been given the total intensity for the resultant wave, so that's why for the resultant wave I resultant should be equal to K into square of resultant amplitude, so this resultant amplitude should be equal to AP plus AQ, then it should be squared. So which gives me this thing equal to I is equal to 3I, so it's equal to 3I is equal to some constant K, then AP is 1.5 plus AQ is equal to simply AQ then squared. So now let's do mathematics on this. So if I divide this thing by this thing, I will have 3I by I is equal to some constant K 1.5 plus AQ whole square divided by K 1.5 square. So I and I goes, K and K goes. So the only thing that we have is 3 equal to something. So if I take the root here, I will have root 3 equal to 1.732 will be equal to 1.5 plus AQ whole divided by 1.5. This will be equal to 1 plus AQ by 1.5. So this when multiplied with this, so this 1 goes to this side, it will become 0.732 is equal to AQ by 1.5. so AQ will be equal to 0.732 into 1.5 equal to when it in calculation, so it is 0.732 into 1.5 becomes 1.098. so when I round it off in 2SF, so 2SF given here, it becomes 1.1 and then centimeters. So the resultant amplitude becomes 1.1, amplitude of the second wave, Q wave, will be equal to 1.1 centimeter. So in the next question, the apparatus shown in figure 5.1 is to produce an interface pattern on a screen. So as usual, you can see this pattern in the books a lot. Light of wavelength 680 nanometer, so it's equal to lambda, is incident on a double slit. The slit separation is A, so as usual. The separation between the adjacent fringes is X, so it is fringe width we often call as. So white to white or black to black is equal to X. Fringes are viewed on a screen at a distance D from the double slit. So all the symbols have their usual meanings, so nothing different. So now in the next page we are said Distance d is varied, so that means this d is varied. The screen is brought somewhat like this, varied from 2 meter to 3.5 meter. So 2 meter to 3.5 meter, as given by the x-axis of the graph here. The variation with d of x is shown in figure 5.2. So as d varies, x varies. So I'll just state the equation later, as is shown in figure. So with that figure, we have to use figure 5.2 to determine the slit separation A. So we need to find from the graph, we need to find A. So here we are given lambda is equal to 680 nanometer from the previous page, that's equal to 680 into 10 to the power minus 9 meters. Now the equation for relating all these quantities is lambda is equal to ax by d. So here we have x in the y-axis and d in the x-axis. So I change the equation here. X is equal to lambda d by a equal to lambda by a and d. So d is in the x-axis, this x is in the y-axis, so this remaining term should be equal to the gradient. So gradient is equal to lambda by a, or I'll have this a is equal to lambda by gradient. So lambda is equal to, given here, it is 680 into 10 to the power minus 9 divided. So when is equal to, if I take this triangle here, from here to here, if I take this triangle here, I will have, so this delta in y-axis is equal to, this delta, this change is equal to, it is 2 millimeter, which is 2 into 10 to the power minus 3 divided, this axis will be equal to, from 3 to 2, it's equal to simply, it is 1. So the value is equal to somewhat like this. So 1 doesn't carry meaning here, simply divided is equal to the same quantity, and this value will be equal to 3.4 into 10 to the power minus 4 meters. So it's done in the calculator, and I did have this value ready made with me, so I just use this. So a is equal to 3.4 into 10 to the power minus 4 meters. Now the laser is now replaced by another laser that emits light of a shorter wavelength. So that means lambda is less. Now on figure 5.2, sketch a possible line to show the variation with d of x for the fringes that are now produced. So we have to draw the same graph of x versus d for this particular wave. So if lambda is less, what we have now is, let's follow the equation here, grad equal lambda by a. So since we have got gradient is equal to lambda by a, less lambda means the gradient will be less. Also, by following the same equation here, so x equal to lambda d by a here, if lambda is less, the value of x also should be less. On the one hand, we have got the slope is less here, and on the other hand, the value of x is also less. So that means x less here, let us say like this, and then slope also less. So the probable line should be equal to from here to here maybe. So I draw it somewhat like this. So this fulfills that criteria here. The value of x at any instant also less, and then the slope also less. So that scores full marks.